Dear students, good morning. Today we are going to discuss about the lesson atomic structure. Structure means what? Shape of an object. For example, when you consider scale, the shape of the scale will come to our mind. Similarly, in the case of a pen or in case of a pencil. So in the world, we already know every substances are made up of a particle called elements. Do you know how many elements have been found so far? Yes, 118 elements. Out of this, 92 elements are found in nature and the remaining 26 elements are synthesis in the laboratories. Can you name some nature elements? Yes, gold, silver, iron, copper are found in the nature. So in case of laboratories, plutonium, neptunium are the elements, some elements found in the laboratories. So every element are made up of minute particle said to be atom. In the Greek word, atomos means indivisible particle. So the Greek scientist Democritus and the Tamil poet Aveyard have also been explained about the atom, but they did not explain the structure of the atom. So the first person to explain structure of the atom is said to be John Dalton. Then followed by him J.J. Thomson and then Rutherford. In this lesson, we are going to discuss about the atomic theories at various times and the molecular formula of the element, balancing equation of the elements. Okay, now we move on to Dalton's atomic theory. This theory was proposed by Dalton in the year 1808. He predicted a model of an atom and then he said every element is made up of minute particles said to be atom. The atoms of same element have the same properties in all the aspects, that is the size, shape and their properties. Atoms of different element have different mass, different shape and different properties. And the next, atom can neither be created nor be destroyed. It is an indestructible. That is, it either changes to one form to another form, but it cannot be fully eradicated. So some atoms combine together in a fixed ratio and form a molecule. The atom takes part in a chemical reaction. Whenever a chemical reaction is taking place, there will be surely change of atom will be taken. Now we are going to see the advantages of Dalton theory. He had explained the properties of liquids and gases. And he also explained the law of chemical combination, that is formation of molecule has been explained. And the next one, law of conservation of mass, that is before the reaction and after the product the value remains the same, that is said to be conservation of mass. Even though there are some advantages, some disadvantages also, that is limitations are there in the Dalton atomic theory. So in case of limitation, when we say the atom was no longer an indivisible particles, because after the invention they said atom composed of subatomic particles, proton positive charge, electron negative charge and then neutron neutral charge, that is no charge present in it. So the next one, atoms of same element have different masses, that is said to be isotopes. Here chlorine 17 and 35 and chlorine 17 and 37. And the next one, atoms of different element have same masses, that is said to be isobars. For example, argon 40 they have the same mass and then calcium they have the same mass. So these are the limitations. And then the carbon is the main compound for gold, graphite and diamond. But each of them differ in their properties. These are the disadvantages of Dalton's atomic theory. Now we move on to fundamental particles. Fundamental particle means what? That is the atom, the subatomic particles, protons, neutrons and electrons. Now we are going to see discovery of the electrons. In case of fundamental particles, when you say William Crookes in the year 1878, he conducted an experiment with a discharge tube. So discharge means a small gas will be inserted and then experiment will be conducted. What happened? He saw an invisible ray moving from cathode to anode. So the tube is said to be Crookes tube or cathode ray tube. Further, the same discharge tube is taken for the experiment and they conducted various experiments and found out various fundamental particles. So this is also known as cathode ray tube, that is CRT, they used to say cathode ray tube. Cathode ray tube is a long glass tube filled with gas and sealed at both the ends. So both the ends it is fully covered. It consists of two metal plates. So one metal plate is set as anode and another set to be cathode, and it is connected to a high voltage. The negative terminal of the battery is said to be cathode and the positive terminal is said to be anode. In the tube you can find a side tube which is connected to a pump. Through the pump, low pressure is made to pass inside the discharge tube. Now we are going to see discovery of electrons, that is negative charge. When a high voltage of 10,000 volt is applied to the discharge tube containing air or gas at atmospheric pressure, here no electricity is made to flow. When the high voltage of 10,000 volt is applied at a very low pressure of about 0.01 millimeter of mercury, a green color glow is observed on the walls of the discharge tube. So it is found behind the anode. So it is observed that some invisible rays coming from the cathode, and these rays are called cathode rays and they are named as electrons. Now we are going to discuss properties of cathode rays. So the cathode rays always travel in the straight line from cathode to the anode, and then it possesses mass and kinetic energy. It is deflected by both electric field and magnetic field. So if it is deflected towards positive direction, then the rays that come out is said to be negative charge particle. And the next one, it does not depend upon the gas that is inside the discharge tube. Now we are going to discuss about the discovery of protons. So the positive charge particles in the atom is predicted by Goldstine experiment based on the concept that the atom is electrically neutral. Neutral means what? Both positive charge and negative charge should be equally balanced. From that he predicted that positive charge particles are present inside the atom. Goldstine repeated the cathode ray experiment by using a perforated cathode, that is small holes will be present at it. On applying high voltage under low pressure, he observed a faint red glow on the wall behind the cathode. As these rays originate from the anode, they are known as anode rays. They are found as a stream of positively charged particles. So anode ray can also be called as canal rays or positive rays. Now we move on to properties of anode rays. Like cathode, the anode rays also travel in a straight line. It possesses both mass and kinetic energy. It is deflected by both electric field and magnetic field. But it depends upon the gas in which the discharge tube is present. So what type of gas we are using, according to that only this anode ray will work. Next we move on to discovery of neutrons. So during J.J. Thomson period, only they discovered protons and electrons. And then at 1932, James Chadwick introduced one more fundamental particle, that is said to be neutron. That is properties of neutron. When we say it has neutral charge, that is no charge will be present in it. So the neutrons more or less equal to mass of the proton. Its value is equal to 1.6 into 10 to the power minus 24 grams. Now we discuss about Thomson atom model. J.J. Thomson proposed the atom model in the year 1904. So in this model he says the atom is made up of a sphere having a radius of 10 into minus 10 meter. So here the positive charge are uniformly distributed. Okay, so that the electrons are also present in it and makes the atom neutral. This model is also known as plum pudding model or watermelon model. You can see the watermelon and the edible part of the watermelon, that is the red color, is said to be positive charge, and then the black color seeds that are embedded here and there, that is said to be electrons. Both positive charge and negative charge are present equal in number, so it is electrically neutral. And then one more he says the mass of the atom is uniformly distributed in all the parts of the atom. Even though he have explained the atom is neutral, but he could not explain how the positive charge particles are shielded from negative charge particles. And then he explained only protons and electrons, but the neutron was not explained by him. So it is a disadvantages towards Thomson atomic model. Now we are going to discuss about valency. Before knowing about valency, we have to first understand Rutherford atom model. So Rutherford said the atom consists of subatomic particles, proton, electron and neutron. Proton, as you have already known, positive charge, and electron, negative charge, and neutron, no charge. So proton and neutron combine together to form nucleus. It is present at the center of the atom, and the electrons are revolving around it in a circular path known as orbit. So this circular path, each atom may have large number of orbits in it, out of which the outermost orbit which possesses the electrons is said to be valence electrons. So the valency is said to be combining capacity of an electron. That is, either it may gain an electron or lose the electron or share the electron during the chemical combination, and then final result will be given out. Now we are going to see the valency two types, positively charged and the negatively charged. Regarding positive charge, we consider atoms of metals having the outermost orbit 1 to 3, that is said to be positive charge. For example, in the outermost electron, they used to have only 1. In case of sodium, when we consider, in case of the first orbit it has 2, and the second orbit it has 8. 1, 2, 3, 4, 5, 6, 7, 8. And the last orbit it has only 1. So here it has 2, 8, 1. So when this electrons wants to attain stable state configuration, that is, either they have duplet or octet, either outer atom 2 or outer electron 8. In case of helium, it has only 2, and in case of neon, it has only 8 in its outermost orbit. Here when we say sodium has 11 electrons, it can be placed like this. So it is ready to lose 1 electron. If 1 electron is lost or it donates then it is said to be positive charge. Similarly, in case of negative charge electrons, when you say all the atoms which have its outermost orbit, this outermost orbit, either 3 to 7 electrons, then they are said to be negative charge. For example, here we are given chlorine 17. So the same we have 2, 8, the outermost orbit it will have 7 electrons. Now it is ready to attain or gain 1 electron from the other atom to attain its stable state configuration. If it gains electron, it becomes negative charge. Then we move on to valency with respect to the atoms. Either it may change like this, or when combining with other atoms also, the valency may change. Here I have given the values of hydrogen and then chlorine and oxygen. So hydrogen, when we say it has only 1 electron in its outermost orbit, it is ready to give that atom. So it is taken as a standard value. So whatever element combined with it, you will have the value of the valence electrons. For example, so the hydrogen chloride means hydrogen value 1, and then water molecule H2, oxygen O. So oxygen value is said to be 2. In case of ammonia, NH3, so value of nitrogen is 3, and in case of methane, CH4, value of carbon is 4. Then with respect to chlorine, when we consider, chlorine also used to have only 1 electron in its outermost orbit. So when it combines, that valence electron value we will get. For example, sodium chloride, each has 1 valence electrons. In case of magnesium chloride, magnesium has 2 electrons in its outermost orbit and chlorine has 1. While we are writing, we have to interchange and write. So magnesium chloride 2. Valency with respect to oxygen, when we consider, the valence of oxygen is 2 when it combines with the other atoms. If magnesium is 2, oxygen only will write as magnesium oxide. And the next one, move on to variable valencies. So with respect with 1 or more element combined together to form more products, then we have variable valencies. For example, copper on reaction with the oxygen form cuprous oxide and cupric oxide. So if it has less value, minus symbol I have to put, and the equation you have to write suffix OUS. So in case of copper 2 plus, the valency is more, then in the suffix you have to write IC, that is cupric. Or either in case of Roman values also we can take copper 1 and then copper 2. And one more example you can say iron Fe2 plus ferrous or iron Roman letter 2, Fe3 plus ferric or iron Roman letter 3. Similarly in case of magnesium, Hg plus mercurous or mercury Roman letter 1, Hg 2 plus mercuric or mercury Roman letter 2. Similarly in case of tin, Sn2 plus stannous or tin Roman letter 2. That is if it has low valency. If it has high valency, Sn4 plus. The suffix is IC. I already said stannic or tin Roman letter 4. Now we move on to ions. What do you mean by ions? An atom or group of atom when combined to form a chemical component or compound. So they may either lose the electron or gain the electron. They are said to be ions or radicals. It is of 2 types, cations and anions. Positively charged and then negatively charged. For example, when we consider sodium, we already said sodium have 11. It has only 1 electron in its outermost orbit. It is ready to lose the electron. So while losing, what happens? That atom, it will have large number of positively charged particles. So positive charged particles will be more in it. Then it is said to be cations. Regarding anions, opposite to that. So here in place of chlorine minus, we have 17. Already we know it has outermost atomic number is 17. So outermost electron it will have 7. It is ready to gain 1 electron. So as it gains, it becomes negative charge. So large number of negative charge electrons is present means then it is said to be anions. Various types of anions are there, that is monovalent, trivalent. According to the electrons how we are combining, those values you will get. Now we move on to chemical formula. What do you mean by chemical formula? The shortened formation of the equation can be written by using a chemical formula. So how we can write? For example, I will explain to you with calcium chloride. So positive charge electrons should be written as a first one and the negative element should be written as a second. So that is the left hand side, positive electron, the right hand side negative electron. That is Ca plus, chlorine minus. Then you have to write the valency values. That is Cl will have 2 and then Cl will have 1. So while writing the element, interchange of the value in the subscript you have to write. So first value you have to write on the superscript at the top end, and the next after interchanging you have to write in the subscript. That is CaCl2. That is the chemical formula or molecular formula for calcium chloride, CaCl2. Naming the chemical compound. So when two or more elements are combined together to form a chemical bond, we have to give the names. So there are 3 cases. First one, when the metal combines with non-metal, how we have to write? First we have to write the metal name. For example, sodium chloride. First sodium we have to write, then the non-metal name, chlorine. Then second case, in combination of metal with non-metals and oxygen. If 3 are combined, first you have to write the metal, sodium, then sulfur, then oxygen. Sodium sulfate. Okay. The next move on to third case, when 2 non-metals are combined together to form a compound. So 2 non-metals means in the prefix value we have to add either mono, di or tri. So in case of this sulfur dioxide, we have to name like that. Next we move on to chemical equation. What do you mean by chemical equation? It is a shortened formation to write the name of the formulae and the symbols. That is why equations going on, we can't able to write the full name. So we can use the symbols for mentioning the reaction that taking place. So there are 2 methods. First one, skeletal equation. In case of skeletal equation, first what you have to write? You have to write the metal name. That is magnesium plus sulfuric acid. So the reactants should always be written in the left hand side. If 2 elements we are adding, we have to use plus sign. For example, reactants on the left hand side, Mg plus sulfuric acid, H2SO4. So when 2 elements when we are adding, we have to put plus sign, then followed by an arrow mark. So you get magnesium sulfate plus hydrogen. So if the gas is evolved, we have to put the arrow mark upward direction. When we are getting the precipitation, the arrow mark should be in the downward direction. This type of writing is said to be skeletal equation. Now we are going to balancing the chemical equation. For example, when you consider hydrogen plus oxygen combined together to form water molecule H2O. So we can balance left hand side, this is said to be the reactant, this is said to be the product. So both the 2 values should be same. So hydrogen here you have 2, here also you have 2, but oxygen 2 you have here no values, only 1. So we can equate the subscript value we can't able to put, but here we have to put 2. So 2 H2O when we say, what's the hydrogen value? Here hydrogen 2, but here hydrogen value is 4. So when you add 2 here, hydrogen value 4, here also hydrogen value 4. Regarding oxygen value 2, here also 2O. that is oxygen value 2. This is how we have to balance the chemical equation. First you have to reactants values, hydrogen value, oxygen value, then the product of the hydrogen value, oxygen value, then you have to balance on both the sides. Why you have to balance? So in order to have information of quantitative and qualitative matters, that is how many number of molecules present and what are the elements that are present. This information can be obtained. So some informations are not given by this balanced chemical equations. When you say that how much temperature that the reactant taking place, what is the speed of the reaction, and then those values cannot be explained from this balancing equation, because both sides it is balanced equally. Okay. So the reactant process is different from that of the balance in the chemical equation. Then let's move on to law of chemical combinations. So in case of the experiments we are doing, various steps of results can be obtained. So in order to classify or state, we have the laws. So that law is said to be law of chemical combination. With this only we have to substitute. For example, law of conservation of mass, the law of constant proportion, law of multiple proportion, Gay-Lussac's law. These four are said to be law of chemical combination. But for us here, only two laws given. Only law of conservation of mass and another one law of conservation constant proportion. So what do you mean by conservation of mass? So the mass of the reactant and the product should have a relationship. It was found by the scientist Lavoisier, and he states that the mass of the product should be equal to mass of the reactant during the chemical changes. So what it says, that is mass atoms can neither be created nor be destroyed. So the mass before value should be equal to that of the after reactant, that is the product value. This is said to be law of conservation of mass. It is also known as law of indestruction value. Okay. Then next move on to law of constant proportion. It was given by the scientist Joseph Sprouts. He said in any chemical reaction, the elements are always present in definite proportion by mass. That is, for example, we can say water. From various sources we are getting the water. In case of the rain, and then water vapor, or in case of the ice from it. In all the three cases, three states of matter, when you say the water molecules, it has hydrogen and oxygen in the ratio 1:8. So he says in any chemical reaction, the definite proportion of mass will be present. Whatever the compounds may be at a different experimental values we can obtain, but the final result what we obtain, we used to have same definite proportion of mass. So this law is also known as law of definite proportion. Constant proportion or definite proportion, both the same. Thank you, students.